Take it away, folks.
Alright guys, we are the Health Mat team, and we're going to walk you through our design review. So first, just to reiterate, our mission statement for this particular project was to develop a comfortable system for residential bedridden patients in particular. And this system seeks to reduce the risk of pressure ulcer formation, and it also seeks to reduce joint stiffening while at the same time minimizing the routine effort that caregivers have to put in to take care of the separate patients. The main functional requirements of our system were first and foremost to be safe. It has to meet a target cost. There's many other systems out there but are quite expensive. So our system has to be able to meet the target cost between $500 and $1,000. It has to be able to do not only microscopic motions like relieving pressure points, but also do joint actuation. And for that, we're going to explain to you later what are the particular mechanisms that we selected for this. So this is an overview, a high-level overview of what this distinguished schematic is going to be like. So from a front view, we have from the floor up, we have the floor, the bed frame, and then we're assuming the standard mattress size that are used in hospitals. This is like a queen size. So then we have the mattress, the patient's mattress. We have a C-frame that is layered on top, encapsulating the mattress. We have rails on each side, and then we're going to have a carriage mechanism that can slide across along the longitudinal axis on the mattress. And this carriage is going to have rollers and bladders that are going to be taking care of this like pressure point relieving and joint actuation. Then we have a mattress topper and then the patients. So the bed frame and the mattress, the system is designed to be to complement the existing. We're not going to replace the person's own mattress that they own. We're going to provide a system that they can just layer on top of their existing mattress. And for that, we have to assume standard sizes, and we decided to go with a twin size.
So the way that our system is going to be supported, we thought for a little bit about having the system be supported from either the ground or the frame of the bed, but instead we decided to have it supported on the mattress itself. This way we can have a lot of the weight of the person distributed to the mattress as opposed to another structure, separate structure. But also it allows us to already know at what height our device is at. So for one of the things that we're going to have is a carriage that runs along the length of the bed. And if we already know that the ends of the mechanism are on the mattress level, then we can make some assumptions about how much pressure or how much contact is being made by the carriage at the center of the mattress. Also, this way we don't have to make any assumptions about either the height of the bed or the thickness of the mattress as well. So the way that the system is going to be working is that we have a sliding mechanism attached to a rail on the side of the bed. So we have this linear rail that's attached to those C-frames that we were just talking about to go over the mattress. And these are going to be made out of 80-20 extrusions. And then this will allow us to add in a slider in there that's padded with PE, polyethylene pads to have low friction. And and the sliders are meant to run along the entire length of the bed. This way we can move a carriage that is kind of shown over there from the foot of the person all the way up to the head inside the stomach. This is the linear motion system. This is how we're actually going to be powering the motion of the carriage. So right now, what we're constructing is that we have these two pulleys with a belt-driven system and running along the length of the bed. And the belt is attached directly to connection to the carriage, so that when we have a motor attached to either one of the pulleys, it'll drive the carriage forwards and backwards. And then over here is just a close-up of what each of these pulleys is going to look like and what the entire system is going to look like.
So for inflating and deflating this ladder that we're going to have fixed on these the carriage mechanism, we need a pump, and we need to be able to, so this ladder is going to be able to travel along the longitudinal axis of the bed. Then we need to be able to have a hose to inflate it, but it has to be long enough to so that it doesn't doesn't pop out the connection between the pump and the bladder. But we don't want to create a mess of like that hose like hanging around on the floor. So what we decided to do was to have a hose that is in the form of like a recoil. So there's going to be a tube underneath one of the rails on one side of the bed, and it's going to be the hose that recoils wrapped around that, and then when the slider mechanism travels, say, from the head to all the way down to the feet, then this is going to extend, and when it comes back, it retracts. And then the pump is going to, it has like the one that we're going to purchase, it's very similar to this one. It inflates and deflates, and then it has this hooks that you can then hang the pump on the frame of the bed on the back.
Okay. So the next aspect of the system that we need to consider is the interface between the linear motion and this carriage that's moving along the bed. And I think this is one of the more mechanically challenging aspects of the system, because we have this thing that's moving under the patient that's going to be experiencing a variety of forces and torques due to interacting with the patient, and the layer between the patient and the carriage itself. So we need to have particular concern for the interface between the linear rail and the carriage, and we looked at a couple of different options for this, including something similar to a bogey on a train track, the ability to have misalignments between the two sides of the rail and not have it jam. So one concept we're looking at, and this is a little busy, is an interface where the vertical connection between the linear slide and the connection to the carriage has some compliance to allow for lateral motion, and then there's tension with springs between the 2 points so that there's some compliance in this direction where it can travel and be slightly misaligned and still not jam. And the next element of the system is the actual interface between the carriage and the patient. And the basic concept that we have for this is a very simplistic sort of design where there is a carriage that is moving up and down the bed. So this would be attached on the two ends here and here, and then at the front and back of the carriage there's a cross rail that has some sort of semi-compliant rolling mechanism. Right now we're just thinking we can use pool noodles for very quick prototyping and testing and iterating to interface. So there'd be a cross-section of PVC that's semi-compliant with pool noodles on it to provide additional variation.
So the inflatable bladders are going to be, where you have in mind having two bladders, one on each, so that we can actuate each leg, for example, independently, but it could also work with one. For now, we have the design having two bladders, and this is the size of the bladder that we selected, that it has like this sort of dome shape. And then the idea is that when the bladder is inflated, it's going to cause, this is the mattress topper, it's going to cause deflation, and then the person's leg is it's on top of that, and then you can then be able to like activate the patient's like knee joints, or if you move the bladder along the bed, you can also activate different parts of the body. And when it's deflated, it's in this position, so it's going to be housed inside this like slider mechanism.
Okay, and then the last layer of the system is a purely passive element where we just have some sort of memory foam layer between the carriage and the patient itself, just to provide distribution of pressure. We've done a fair amount of work with this where we used a substantially thicker thickness, 6-inch memory foam, and that provided too much distribution of pressure, so when we inflated this bladder, it kind of just provided a very broad shift in the surface contour of the bed rather than actually any sort of localized movement. So we've also gotten a 1-inch and a 3-inch memory foam topper, and we're going to look at some of the trade-offs between the thicker material and the greater pressure distribution. want to coat the top layer and under layer of the mattress topper to reduce friction between the carriage and the mattress topper, as well as to provide a moisture impermeable barrier between the patient and the topper, because people who are bedridden often have issues with incontinence.
Great. If you guys have any feedback, please let us know.
Yes.
I have a question. It's a very good presentation. So one of the main goals of this is to reduce pressure sores, which one of the main locations for that would be on the hips or the buttocks. How would you position, what would be the optimal position for these actuators to reduce pressure in that area?
So I think the general approach we've seen here, and some of this is based on some testing we did with the shiatsu massager. I think we showed some video of that last presentation, and we found that by having a relatively thick layer of padding between some actuation element and the patient, you provide a pretty good amount of pressure variation on a large scale. I don't know if there's anything here that specifically addresses those bony protrusion regions as opposed to just the general interface with the body, but at the same time, a lot of existing systems don't necessarily either unless they have specific contours with that. So I think it should accomplish that reasonably.
One, just quickly, to bear in mind that when you have a photo of those, that's one thing that's in the graph as well, just to make sure you can take that into account. And the other is, just to have some quick analysis into the forces translating from the body to the carriage. What is that going to do to the frame? Because ultimately, you have the person on the mat, so that would push from the person to the mattress, and then you're pushing against that, and then your frame is pushed, and how does the frame attach to the mattress?
Yeah, so that was one concern. I think I even made a brief note in the presentation. Right now, the frame is a pretty large loop. The K in that KX is not very large. And I think we need to do something with adding additional cross bracing under the mattress or in the sides to try to alleviate that issue. But that is definitely something I think when we assemble it, and we're going to quickly have to make some additions to that frame element to increase its thickness.
Have you done calculations to size your motor?
Yes.
We've looked at the amount of power that it needs to go through, and right now, based on some assumptions that we made about the velocity that we're going through, as well as the coefficient of ratio, we're looking at something around 3 watts approximately.
I have a question. Suppose a patient is way over on one side of the bed for whatever reason, and not perfectly centered. Have you considered the effects of what the differential friction across that rail beam could be?
So I think in some of our design, we've kind of made the assumption that because this is a system that's interfacing with a patient who also has a caregiver, we can make some reasonable assumptions about them being centered, but it would certainly be worth doing more investigation.
You've got to have some tolerance.
Yeah, to off-center. And I think that would be reasonably handled by that intent that there's the ability to handle some inconsistency in the position of the two railings.
Let's have the next team get ready to go. We'll take one more question while we're getting set
Are
up.
you driving both sides of the carriage? Do you have a belt on each side of the carriage?
Yes.
What is your plan for control of that LPI system? Are you going to have just limit switches and just have it keep turning the crank when it goes?
So we're going to have a motor feedback to know the position of the motor. And we're also thinking switches at the end. We've seen other similar systems that have incorporated separate.
So 2 comments. First of all, you guys, thank you for presenting. So when you say, well, I know we're going to build it and find